Hello. Thank you so much, and good morning, everyone. สวัสดีครับทุกคน So we're here to present the topic and architecting the security onion for enterprise resilience. I'm Pirun from Chaitech. I'm with my colleague, Kun Galawit and Kun Pirafong from Chaitech. So in this talk, we are going to discuss about a case study in scaling the open source SIEM, which is the security onion. So we have an experience over 1 year developing a custom feature for security onion, right? For open source SIEM for high performance threat detection. So we are pleased to share our insight and our finding with you guys. All right. So who am I? Who we are? So we are a group. Can anyone hear me? All right. So we are a group of researchers from a research lab, our lab called Applied Network Research Lab. Most of our work working on high performance network. So initially we are starting by focus on a firewall and filtering solution, which lead to develop a monitoring solution, especially the network monitoring solution. But right now we are quite shift our focus to security things. So we develop our product based on the log collector and SIEM right now. So this slide show our development stack, our technology stack that we used to develop for over the past year. There are so many stack. There are so many platforms that we are using, but there are so many more. Our full stack is flexible. It's very depend on the project that we develop. So, but the core of this stack also the same, that we try to optimize the processing of the packet processing or data processing of our product. So you may familiar with this too? Did you guys familiar with this one? I guess you are familiar with the a tick stack, ELK stack, or just Licata like that. Well, quick disclaimer to set the context for our presentation. All right. First of all, what we are sharing today is based on our experience to develop a custom feature of SIEM solution and open source SIEM solution for over the last year. The goal today is to discuss the engineering and technical aspect, the engineering and technical perspective of the open source SIEM. So it's important to note that this is a case study, so we are not using any real or any sensitive data. So what we are showing today is just a demonstration purpose only. And we believe that it's important to share our journey and lesson we learn, but please keep in mind that every organization needs a unique solution. So this is just our perspective. It does not reflect any official policy or policy of our company. Here is a brief introduction of our talk today. We will start by discussing why we use an open source SIEM in the enterprise. Then we discuss why we use a security onion and an overview of the architecture of security onion. And then we will deep dive into all custom enhancement that we improve the performance of the security onion. This is an important section because this one is show how we develop our system. All right. And next, we are also address an ongoing challenge. Like now, we still cannot so that, but there are so many challenges. And after that, we summarize our talk, and I hope you get a key takeaway from our presentation and the lesson learned. All right. Let's start by why we use the open source SIEM. The key lesson behind the open source SIEM are the cost effective. The most important thing is the cost effective. The other is an option. But I show you the 5 key advantages here, which is the cost effective, flexibility, transparency, community support, and scalability. All right, let's go through each of these in more detail. The cost effective, the open source solution can lead to the open source solution can lead to significant lower license cost. It actually eliminates the software license fee, which is can be a major expense for commercial SIEM, especially when your organization data grow. So this allow you to allocate your budget to other security needs. Secondly, the open source SIEM offer incredibly flexibility. So you have an open source SIEM, you may develop anything on that, allow you to develop a fit solution into your organization need and help you avoid being locked by a vendor. So transparency, right? So the open source software that you can investigate the code yourself. So it can lead to you may fix the bug, or it can lead to faster bug fix and vulnerability patching. It's a community of global developers. It also enhances your security confidence, so you can see exactly how the tools work to meet your standard. And also the strong community, the strong community support. There is a global community of developers and users who contribute to rapid development and troubleshooting of the platform. This means that when the issue arises, you have your expert and a network of experts to turn to. Finally, another very important thing, the scalability. So when you use an open source SIEM, the scalability when your organization data grows at your network, your organization, your branch, plan, or you have a customer and data volume increase, you can scale the platform accordingly without a major financial barrier. So open source SIEM often build on distributed big data architecture, for example, an ELK, if you're familiar with that, and an Elasticsearch stack, it designed to scale horizontally. This means that you can add more nodes to the cluster to increase performance power, to increase storage, to increase search capability. We go with it, but however, they still have some disadvantage. It's important to aware that the open source SIEM still have disadvantage. This include a high level of experts to deploy and to maintain the system. SIEM contain a lot of system in it. You may see after the Kun Kolowit talk, in open source, in security and onion, there are so many open source software inside that security onion. So yeah, they require a lot of technical expertise. So they also have a lack of data support, which is optional. They also have a hidden cost, which is related to you need to hire an expert engineer to implement and maintain your system also. And the last one is limited feature, which is why we are here today, why we are talking today, because the limited feature they have. So we need to improve. We need to develop a custom enhancement, a custom feature to fit an enterprise need. So I have now provided you with an overview of our team, overview of our work, and the open source SIEM solution. Now, next, my colleague is going to take over to discuss about why we choose Security Onion and how we improve the solution to fit into the enterprise solution. Yeah. Kun Kalavit Kap. Please give him a big round of applause.
Yeah. Thank you, Pirun. As we just heard, this is okay, yeah. With open source SIEM solution bring many benefits. They also come with a challenge such as a limited. Yeah. Hello? Yes. Is this okay? As we just heard, while open source SIEM solution bring many benefits, they also come with challenge such as a limited enterprise level feature and the need of security and technical expertise. With that in mind, after evaluating several open source SIEM platforms, we decided to adopt Security Onion as our core foundation. We made this choice because Security Onion offers one of the most comprehensive set of capabilities in the open source space, and it's backed by a very strong and active community. Of course, we also recognize that open source platforms are not perfect. Some critical and enterprise features are missing. So our chosen path was clear. Take a Security Onion as base and then customize and enhance it to meet requirements of an enterprise environment. While open source solutions offer many Before we continue, let me share a quick disclaimer. Okay. Security Onion also have a Pro version which provides certain enterprise-ready features. For our project, we aim to maximize cost efficiency and flexibility. That's why we decided to adopt an open source version of Security Onion and then develop the additional feature we need to on top of it. What I'm going to share today is therefore based on our experience and engineering effort, not on the official Pro version. Specifically, our customization were built on the Security Onion version 2.3, which was a stable release at that time. In previous slide, I mentioned that we choose security as our platform. But as engineer, we don't just choose the tool. We need to be very clear about why it worked for us. And when we look at the Security Onion, two core strengths really stood out. First is, it is all in one. This means that it does just give us one capability. It combines network monitoring, endpoint visibility, log management, and even incident handling into the single system. For the SOC team, having all of this integration in one place is extremely powerful. Second, it is both practical and supported by a strong community. By practical, I mean it's easy to install, configure, and operate. We don't have to spend a week integrating different parts before we can even start. And the community around the Security Onion is very active, continuously improve the platform, contributing enhancement and providing help when issues arise. So these two strengths, being all in one and being practical and strong community support, gave us the confidence to adopt it as our core platform. In the next slide, I will break this down and show that what they look like in practice. The first thing of the Security Onion is that it's truly all-in-one. It gives us full visibility across both of network and the host environment. On the network side, it includes NSM and IDS IPS capability powered by Suricata and 6. And on the host side, it includes the endpoint detection and response, give us log and event data directly from endpoint. Having both perspectives together in the single platform means we don't need to integrate the multiple separate tools. It gives our security operation team a complete picture right out of the box and allow them to work faster and more efficiently. Another part of the all-in-one strength is the case management. Security Onion allows analysis to create, tag, and resolve incidents directly in the dashboard. Instead of switching between different systems for alert, ticket, and investigation, everything is in the one place. This makes the workflow much smoother. For example, when we detect an alert, we can immediately escalate it into the case and assign it into team member and tag it until closure. This build capability makes a big difference in day-to-day security operation. Now, apart from being all-in-one, another reason why we choose Security Onion is what we call practical and community power. By practical, I mean the platform is simple and straightforward to work with. For deployment to scaling today, it's designed to be usable without unnecessary complexity. And the community power, I mean the strength of the open source community that actively support driving continuous improvement, enhancing feature, and providing support when issues come up. If we break it down, there are 4 key aspects we look at in the next slide. Easy setup, scalability, strong community, and cost effective. The first aspect of being practical is how easy it is to set up. With the Security Onion, the process is very straightforward. You can start with installing the operating system, and then move to configuration, too simple, and then you can use it. You can already start to use system. I would say this is necessarily easier than commercial SIEM. In fact, many commercial tools have simplified installation as well. But with Security Onion, it is at least on par with some enterprise-scale solution in terms of ease of deployment. The difference is that we, as an engineer, we understand every layer of the system because we configure it ourselves. That makes it much easier later when we need to customize or troubleshoot it. So in the practice, the setup is not only manageable, but it also gives us a deeper understanding and flexibility right from the start. In enterprise environment, one of the biggest challenges we always face is the data never stops going. More device, more log, more alert. And if the SIEM cannot scale, it quickly becomes a bottleneck. So it becomes slow, ingestion drop, or storage fill up. Security Onion address this by supporting horizontal scaling with the different type of node that is serve duplicate load. For example, it has a forward node, capture the traffic and log from the endpoint of sensor and send them upstream. Receiver node, that's one here, are designed to handle very high volume log ingestion. They are just like the integrator of massive syslog stream. Third node is from the elastic cluster where the data index and store, sorting and queuing. And the manager node acts like the brain of the system, controlling configuration, managing detection loop, and providing analysis dashboard. The beauty is the design is that the work like Lego block. You start with some small set, and as your environment goes, you can simply add more block. Add receiver node when the ingestion increase, add server node when you query get heavy, add forward node as you want to deploy more sensor. This modular approach means the platform can go together with the organizations, step by step, without need to rip and replace the entire system. That's why it makes execution practical for enterprise security. It's flexible, incremental, and sustained in the long term. Another important strength of the Security Onion is a strong community. The project is actively support not only its core developer, but also the wide base of users who contribute feedback. The screenshot here shows the GitHub discussion page. This is where people bring up the question, share solution, and report issue. You can see that problems are addressed openly, and both developer and user participate in the conversation. What this gives us is confidence that Security Onion is not a static platform. It's constantly improving and evolving, supported by collective effort of its community. For enterprise environment, this is a kind of active community. Mean we are not relying on a single vendor. Instead, we benefit from the entire ecosystem of contributors, which makes the platform far more sustainable in long term. And finally, one of the most straightforward advantages is security is cost effective. There are no license fee. This means instead of paying for the expensive licensing, we can allocate our budget into something else like infrastructure, scaling, or some customization that directly support our enterprise needs. For organizations that need to balance capability with cost, this is very significantly benefit. Another important point is Security Onion is built on the top of the wide range of open source projects. The first component is a forward, or we can call it the center node. This layer is responsible for the collecting raw data and then forwarding into the manager. It combines with several well-known open source projects. You can see SIEM for the deep network analysis, parsing protocol, and extracting behavior. And there are also Suricata in it. Suricata is for intrusion detection and prevention, using some signature to catch threat. There Strelka is for the file analysis. For example, the extracting data and scan file like PDF or some document or even the malware sample. And last one, we have an Elastic agent which collect and forward log from the endpoint, such as system log or something like Windows event log. In short, this is a front line. It captures what's happening in environment and then send enriched data into the rest of Security Onion platform. Next one is a manager node. Manager node is a control center of Security Onion. This is not designed to store massive amount of data, but instead it runs the core service that orchestrates the platform and provides the interface for analysis. Inside the manager, we have Elasticsearch for indexing and sorting event data, Logstash as a pipeline to process and transform incoming log, Kibana for some dashboard and visualization, Redis, which act like a message broker between service, and InfluxDB, which stores some system health metric. This is also the node where analysis log in to perform investigation, manage case, and update rule or configuration that get pushed to the rest of the entire deployment. Next one is a search node. This node also runs Elasticsearch and Logstash, just like the manager, but its load is very different. It's built for scale. The search node is where the heavy data store and indexing happen. If the enterprise environment grows and we have a higher data volume, we need a faster query. We don't have to touch the manager. Instead, we can simply add more search nodes. You can think it like the Lego block, modular and stackable. In addition, now search node expand capacity, improve performance, and allow more concurrent search. This makes Security Onion high scalable and suitable for enterprise use because we can go the environment step by step without redesigning the whole system. Now let's talk about the reservoir node. This node is very lightweight compared with the manager. it only run two key services, a log stash, which receive the log from the last agent, and Redis, which queue the event so that certain node can later pick them up for indexing. The purpose of the receiver is twofold. First is to reduce the load of the manager by taking over the ingestion pipeline. And second one is to provide redundancy. If the manager go offline, agent can still send the log into the receiver node, and the third node will continue to process event from the Redis queue. Receiver nodes are active, so we can add a multiple of them, and event will load balance automatically. Think of them as an extra door into the pipeline. The more door you have, the more traffic you can handle without congestion. Security Onion already bundle a wide set of open source tools: monitoring, detection, case management. On the paper, it looked very strong, but when we paste it in enterprise environment, we quickly realized something. Being feature-rich being feature-rich does not automatically mean being enterprise ready. Enterprise operate at a large scale with stricter compliance, more integration need, and higher expectation for reliability. That's why security is powerful, but we still need to look beyond what comes out of the box. When we look at the deploying security in enterprise setting, two major gaps became clear. First, the data isolation. Security Onion doesn't separate data by tenant. That means in a scenario like MSSP or organization with multiple departments, one group could potentially be visible to another. Enterprise needs some strong isolation to support to multi-tenancy. Second one is the centralized management, and this actually has the two parts about it. About this section rule, in enterprise, you cannot afford to configure or update rule manually on each node. You need a central place to define, manage, and distributed detection rule across the entire deployment. User management enterprise also requires centralized identity and access control. Right now, security Onion manage user locally, but in the last organization, you will expect to integrate with some cooperating identity system, manage some role from centrally, or apply some policy. Without that, scaling user asset become inefficient and error prone. So when we talk about enterprise gap, it's not only about missing feature, it's about missing the control and governance layer that enterprise depend on. And without closing this gap, Security Onion cannot fully serve as true enterprise SIEM. When we identify the enterprise gap, we're focusing on extending Security Onion with our enhancement. We didn't want to reinvent everything. Instead, we want to keep the strong foundation of Security Onion and the enterprise feature that we are missing. In this project, we work on the four main areas. So first one is the multi-tenancy, second is a single sign-on, and third one is the centralized rule management, and fourth one is high-volume log ingestion. In the next few slides, I will walk you through each of these enhancements in more detail and show you how they help make Security Onion enterprise ready. Multi-tenancy. Multi-tenancy is the concept of having a single instance of software that you can securely serve multiple customers. What this means, instead of deploying one SIEM per customer or per department, we can have a shared infrastructure where resources are reused, but data asset remain completely isolated. For example, imagine at MSSP environment, we might have bank A, bank B, and bank C, and all are using the same system. They share the same underlying infrastructure, but each of them only see their own dashboard. their own alert, and their own case. This made the platform much more efficient, scalable, and cost-effective, while still guarantee that strict data separation. When we look at the security onion, we quickly realized it was not designed of the multi-tenancy. It assumed as a single organization with single set of user and data. So when we try to use it in multi-tenant environment, several problems appear. First, all data from the different clients end up in the one place. That might be fine for the single organization, but for the multiple tenant, it mixes everything together. Second is the mixing introduced a serious list that one client data could be visible to another, which clearly breaks the principle of isolation. Third one is administration became very inefficient. Without multi-tenant support, admin had to manually create an account and manage authorization separately for each client. This not only wastes time but also increases the chance of error. Fourth, any issue with one client could affect two others. For example, if one tenant generates too much load, it could disrupt the stability of the whole platform. And fifth, scaling was inflexible. Support one tenant requires more resources than others. Under the default security onion design, we cannot just scale for the tenant alone. Instead, you have to scale whole system, which is inefficient and costly. So, all of these problems came down to the one fact. Security onion is strong single tenant system, SIEM, but it doesn't provide native multi-tenant support. And the gap that is the gap we set out to solve. Our solution to the multi-tenancy problem was to build a dedicated layer on the top of security onion. For tenant perspective, we focus on 4 key improvements. Single portal for all tenants. Users don't need to jump between the different systems. Instead, they access everything to the unified entry point, easy access. Log in once, then immediately reach the dashboard and they are authorized to use it. Data isolation, all 2 tenants share the same infrastructure. Their log and dashboard are separate. A user from the tenant A will never see data from tenant B. And some are back control, permission and manage per tenant, ensuring the analysis admin and manager only see what they relevant to the role. Now look at the technical piece. The core of our solution was to introduce a central authentication layer. Security onion normally give the tenant its own creators identity system. That design makes sense for the single tenant setup, but it creates a complication when we need a unified experience. So what we did was we built a new central Kratos instance that works as a middleware. Then we reconfigure the proxy in each tenant. Instead of pointing of the own local Kratos, it now points at the central one. When users log in, the central Kratos will authenticate them and issue some UUID and session token. The result is the user can log in once and then move seamlessly across multiple tenants they are authorized for. Meanwhile, each tenant still keep its data isolated and security onion continue to function as intended without deep call chain. Now let's move to the single sign-on or SSO. The idea here is simple. Instead of separate the username and password for every system, You log in once to the central provider and then you gain access to multiple applications. For the end user, this makes life easier. One password, one login. For the admin, it simplifies user management, reduce account overload, and lower chance of the weak or reused credential. In an enterprise, this is a critical. Analysis might use the dashboard, case management tool, reporting system, or more without SSO. They have to log in each separately with SSO. One login unlock all tools they need. When we started implementing security across our environment, we quickly realized that identify and asset management was becoming a major pain point. First, every system requires its own unique login. Analysis had a juggle of multiple username and password. One for the dashboard, another for the case management, and another for the reporting. This was inefficiency and hard to maintain. Second, users were constantly logged in and out of different systems. Switching between sessions slowed down workflow and caused confusion. Third is the sheer number of the accounts creating a real security risk. People tend to reuse or forget password, and each new account adds into the attack surface. Fourth, administration had to create, update, and remove user account manually in each system. This was repetitive, time-consuming, and prone to mistake. And finally, there was no single page to manage user role or permission. If someone role changed, admin had to shut it down system by system, which left gap and bright the spot. In short, with our centralized way of handling authentication and permission, we were dealing with a fragmented, less secure, and harder to manage environment. When we introduced the multi-tenancy earlier, we already built the foundation for centralized login. Each tenant no longer had to manage its own authenticators separately. Now with the single sign-on, we take that one step further. One login for the all tenant system. The benefit is bundled into what we already achieved in the multi-tenancy. Users now sign in just one, not one per tenant, not one per application, but single login across the whole environment. This makes the experience seamless and reduce friction. Easy access and efficiency. Analysis and manager can move between the tenant and dashboard instantly after login. No repeat credential, no section juggling. For enterprise scale environment, this efficiency adds up to a lot of save time and reduce error. Centralized user management. For the administrator, this means one central place to manage account and permission. Instead of repeating the same tasks tenant by tenant, they can update a user once and the chain apply everywhere. That reduces workload and strengthens security. And now we make this possible. We build the central authenticator. Each tenant Nginx proxy, which originally point to its own creators, was configured to point to the central system. For the identity management, we introduced Keycloak as the main provider, with the creators acting like the middleware. This is give us the flexibility to integrate multiple IDP, such as some other SSO or ID, without changing security onion itself. The first user login and Keycloak authenticate them. Creators issue UUID like we talked in the multi-tenancy before. So our single sign-on solution built directly on the multiple tenant work we did earlier. The result is simple. One login for all tenant and system, smoother access for user, centralized management for admin, and technical foundation that flexible and future-proof. Before we dive into the problem, let's further look at Let's first look to the rule that we typically work with security union. First, we have the Sigma rule. This kind like a universal language for detection. Sigma lets us description suspicion behavior in standard way, then translate into the different detection engine. For example, they use Sigma to transform to Elastic. Yeah. Next one is the Yara rule. Yara is more about identifying malware pattern. It works for the file or some binary level. And we have an IDS rule, such as Surikata rule. These are focused on the network traffic. If a malicious packet comes through or it known as an exploit is attempt, Surikata rule help us to detect the right way on the why. Now let's look at the challenge that we face in the rule management. The first big area is what we would call the lack of rule management. And within this, there are actually 3 pain points. First one, the importing rule. Today, importing rule isn't straightforward. Each tenant or each instance needs its own manual process. There are no single place where we can bring in a new rule and then apply across of the system. This wastes a lot of time and increase the chance of human error. Change management. Once the rules are in place, keeping them updated is another problem. Let's say you want to tweak a Sigma rule or modify some Surikata signature. You have to repeat that change in multiple places. There are no built-in workflow ensuring consistent update across tenants. That means some tenants could be running old rules while others are updated. It's a big risk for the detection accuracy. Separate rule store. Added to that, every tenant store its rules separately. This design makes it hard to see what the rule currently active across the organization or to reuse and share rules between tenants. It also makes troubleshooting more complex since each tenant is effectively its own isolated environment. The second major issue is a lack of third-party support. In the enterprise or MSSP environment, we often rely on the threat intelligence feed, custom detection from some partner or some open source rule repository. But integrating this directly into the security union is not smooth. The system wasn't designed to natively pull in and manage third-party source. So again, we end up doing a lot of manual work, which simply not scale. So overall, the rule management process ends up fragmented, manual and very resource intensive. And for the large environment with multiple tenants, this creates a both operation inefficiency and security blind spot. To solve this issue, we build a customized layer that streamlines rule management across tenants. At frictional level, we introduce a central portal where administrator can import, update, and manage rules in the one place. Instead of touching each tenant separately, the portal takes care of the distribution automatically. For importing rules, the portal supports multiple formats, Sigma, Yara, Surikata, and handle the conversion process behind the scene. This reduces the manual work and ensure that rules are consistently applied. For the change management, we add a workforce so that when a rule is updated or disabled, the update is log tag and push across the tenant. This prevents a situation where one tenant fails. This prevents the situation where one tenant falls behind. For the separate storage problem, we build a mechanism that synchronizes rule files across tenants. From the admin perspective, there is only one central responsibility. The portal writes into each tenant automatically, ensuring consistency. Finally, we enable the third-party integration. External feed can now connect directly into the portal. From there, rules are anonymized and distributed. That means organizations can take advantage from community rule set without heavy customization. So this customization will solve the rule management challenge, making its centralization scalable and extendable. And with that, I will hand over to my colleague Pirapong, who will talk about the next challenge that we handle it.
Okay, talk about the technique, the next challenge, high volume congestion challenge. That challenge, we aim to scale our SIEM to handle the 100,000 event per sec data with Security Onion. But Security Onion is not able to support itself. We talk about the technical that we use to present for scaling up to aim that goal. Okay. The next slide, we will talk about the 4 strategy that we present today. The first one is the horizontal scaling, that the way Security Onion do. The second one is log filtering. We need to filter log that and send the important data only to the SIEM to detect threat in real time. Okay. The 3 strategy is dedicate resource that we talk about that we should dedicate separate the network, and we separate SIEM for specific network, allocate that resource dedicatedly. Okay, the 4th strategy is fine tuning the configuration. Okay, we talk about the first strategy. First strategy is the horizontal scaling is support by Security Onion already. This picture will describe you about how to scaling it. The first, this is a 3-tier architecture that you can scale the of tier. The first tier is a forward node. You can scale up on your demand. That's up to your source day of data. The second tier is a receiver node that you can also scale it. That the second we talk about is about receiver node before. It's a work already work the same. And the next phase, the next tier, search node, you can also scale it. Okay, in this picture, the advantage of this method is it's easy to manage it because of you have the one system. But if your scale is over and over, it should more complex, that hard to management. Okay, the second strategy is log filtering. We present the syslog server that filter your log at the central, then send the important log only to the SIEM that you want to detect threat in the real time. This is the advantage of this method is this reduce the computing power. But syslog server is only support the syslog protocol because it's effective when you're using syslog protocol only. Okay. This is about the overseas log server that we developed to support, to scale it. That our developed syslog server can scale up to receive the syslog event more than 500,000 event per sec, and it manage the data from source separately. That you make sure that your data is complete, not modified. Okay, and it is a concept of the central log that we present in this slide. Okay, the strategy 3 is dedicate resource. We dedicate resource for network zone that help you to separate the resource. That this way has advantage is prevent the collateral damage when your system has been attacked because it's not down at all, down on tenants. It's down is effective with the tenant that attack it. Okay. The fourth strategy is fine-tuning configuration. The configuration, default configuration of security onion is so safe, but it can't scale for handle the massive log. That we propose the way to customize the configuration. The first one is you should change the data retention policy in the SIEMs. The second one is you should modify the Elasticsearch configuration, and the last one you should optimize alert engine on Elasticsearch. This method you have an advantage is not require more resource, but it may be not effective. And okay, now this is a change and the suggestion that we suggest you to change the data policy. This is okay. You can look it back. Okay. Elasticsearch, allow Elasticsearch that you choose the tuning. This is a requirement from external source. The first one is you should disable the swap memory for the best performance, and disable the replication. And you should increasing your heap size by default. The Elasticsearch will allocate the heap size of Elasticsearch to be 30% of system. You can be increasing to 50 to 60%. Okay, you should aware about the Elasticsearch because of if you have low disk space available, and Elasticsearch could be prevent the block the write your data in the SIEM that you will be lost data at that time. Okay, and in the second issue is if you suffer with the insufficient heap size memory, it may be lead to the unresponsive and it may be crashing. The third one, use the better hardware. You should we prefer the local storage more than the remote storage, and choice solid state over the hard drive. Okay. Hey, we have another challenge that we talk about. The first one, the challenge is a challenge we have no solve yet, but we have planned to solve it. The first one is threat intelligence management feature support. That's this slide we describe about threat intelligence. I will skip it. Okay, by default, Security Onion support threat intelligence. With the limited function is it can search the data that you have with threat intelligence external within the investigate process that's calling the analyze feature. That we hope that Security Onions could be more complete and support the real-time threat detection with the threat intelligence feature in the log, in the file, and in the network traffic, and in the real time. I think it could have. Okay. Another challenge is about the system version incompatibility.
Another big challenge we're still facing today is a system version incompatibility. Security Onion move very fast. The new version released frequently, and those versions often bring the major internal change, new architect, new service, sometimes even the repairs some whole subsystem. Why this is a great for overall implementation? It creates a constant starting for us. The reason is our system is not just plain Security Onion. We add many custom components from the multi-tenant session management to the rule automation. So every time a new release come out, there's something we rely on. It will break. For example, a change in the way authentication is why can suddenly disturb our center Kratos integration, or a new directory structure for the rule might be break for the automation we build. What this means in the practice that every upgrade become the maintenance project. Instead of the simple patching and moving on, we have to spend a day or sometimes a week or a month to readapting our tool to keep them compatible. And this is a one-time problem. It's ongoing with every new version. We know we need to review, retest, and sometimes rewrite part of our system. It eats up a lot of the engineering time and it slows down our ability to focus on the improvement for the user. So right now, this is still an open challenge we haven't fully solved yet. What we are trying to do is think about the decouple and our custom layer from the core security onion internal. If we can achieve that upgrade, if we can achieve that, upgrade become smoother in the future. But at this point, version incompatibility remain a recurring issue we need to plan around every single time that they release it. Let's wrap up our journey with a short summary. We started by choosing the security onion as a foundation because it competes as an open source SIEM platform. But we didn't stop there. We customized it for the enterprise use it. We customized it as an enterprise use, extending its capability to cover area where it wasn't originally designed to operate. Through our work, we built a key feature that address important gap. For example, we solve the challenge around the user access and multi-tenancy, implementing data isolation to protect the tenant boundary and add more flexible rule management to make security operation smoother. We also develop a central log system to improve scalability and optimize resource utilization. This means the system can handle a large environment and efficiency without overwhelming our infrastructure. And of course, because we build this on an open source foundation, our solution is not only cost efficiency but also highly flexible. We can adapt and extend it much faster than most commercial systems. Let's say it's not perfect. We still lack certain advanced features that are available in some commercial SIEM products, such as the native threat intelligence integration. This remains as a limitation, and we continue to explore how to bridge those gaps. So in short, security gives us a strong starting point. Our customization fills many gaps, but still have a challenge and opportunity ahead. And with that, I will hand over to Mr. Pure, who will talk to the key.
All right, let's do a quick takeaway. So first, they are not one size fit all. So you may need to config, you may need to fine tune the security onion to fit their enterprise environment, or if you a scenario like MSSP, so you need to fine tune it. Secondly, the major problem is also the data. So we learned that to make SIEM truly effective, you need a good filtering to reduce the amount of data being processed by SIEM. So that's it. And finally, we found that customization also achievable and it beneficial. But you also need a high skill of engineer. You also need a lot of budget to implementation and to customize the solution. So that's it for today. I guess we don't have any time right now. But yeah, thank you for having us. ครับ ขอบคุณครับ